Medians and altitudes of triangles. Our objective is to apply properties of medians of triangles as well as apply properties of altitudes of triangles. Who uses this? Sculptors who create models of moving objects can use centers of gravity to balance the objects. Let's look at some vocabulary. The median of a triangle is a segment whose endpoints are a vertex of the triangle and the midpoint of the opposite side. The centroid of a triangle is the point of concurrency of the medians of a triangle. So your medians, you get 3 of them, they will make your centroid. So wherever they intersect. The altitude of a triangle is a perpendicular segment from a vertex to the line containing the opposite side. Think of it like the height of a triangle, but going from every single vertex. The orthocenter of a triangle is the point of concurrency of those altitudes of a triangle. The diagram below shows finding the altitude and then where the orthocenter is. So you want to find from each vertex, you want to meet the opposite side perpendicularly. Well, if it's an obtuse triangle, it's going to appear outside of the triangle. And where those 3 meet, that would be your orthocenter. Let's look at the centroid theorem first. The centroid of a triangle is located 2/3 of the distance from each vertex to the midpoint of the opposite side. Think of it as thirds. So from Z to P is 1/3. From P to halfway is 1/3. And then from that halfway point to B is another third. So 1/3, 2/3. So from B to P is 2/3. And then from P to Z is 1/3. So it might be helpful to split each median into 3 pieces as such. So you have one-third, 2/3, and there's your 3/3. Let's try applying this. Using the centroid to find segment lengths. AF is 9. So from A to F, this whole distance here is 9. And from G to E is 2.4. So from G to E, is 2.4. Now it wants us to find AG first. So from A to G, well, think of it as thirds. So split this into 3 pieces. The whole line into 3 pieces, not from A to G into 3 pieces. So from the vertex to your centroid, that's 2/3 of it. The other third goes to the rest of the way to the line. So what is 2/3 of 9? Well, if we split 9 into thirds, we have 3, 3, and 3. So 2 of them together make 6. Let's try CE. It wants to know the distance from C to E. Well, if 1/3, because that's the part that's going to the side, is 2.4, you know you have another 2.4 and another 2.4. So if you add 2.4, 2.4, and 2.4 together, you end up with 7.2. Let's try finding the orthocenter now. So find the orthocenter of triangle JKL with vertices. J is at -4, 2, K is at -2, 6, and L is at 2, 2. So step 1 would be to graph this triangle. Now that you have your triangle graphed, we can look for our orthocenter. Now to find the orthocenter, you want to find the altitudes. So basically the height of your triangle from different directions, because your height is always going to meet the opposite side at a right angle or perpendicularly. So the easiest one, if you notice you have a horizontal line, if you ever have a horizontal line or a vertical line, play with those ones first because they're the easiest ones to do. So what's perpendicular to a horizontal line? Well, a vertical line is, so go from your opposite point to this line. So you're always playing with opposites in a triangle. And you're going to just draw a vertical line going straight up and down. Alright, so that would be one of our altitudes. You need at least two because your point of intersection is going to be your orthocenter. Your third one is a great way to make sure that you've got it. Alright, so let's look at point J. So we'll change colors here. We'll go pink. We're going to look at point J, and then we're going to look at this line here. Because we're always playing with opposites. So from this point, we want to meet the opposite side perpendicularly. That means we're going to need to find the slope of KL, which happens to be down 1, 2, 3, 4 over 1, 2, 3, 4. So down 4 over 4, which is the same as saying negative 1. If we want to go perpendicular to that, we're going to have a slope of 1 over 1. So that means from your point, because you need a place to start, so from your point, you're going to head to this side going up 1 over 1. And then draw your line. Once again, using a ruler is probably best. Can't really use a ruler on a computer screen. That works all that well. So, now we have our orthocenter. So our orthocenter is negative 2, 4. And that concludes our lesson on medians and altitudes of triangles.